So in this lesson, we're going to be talking about determining if the value in a set of data is a possible outlier or not. And the first thing that we're going to talk about before we get to there is what we call the mean absolute deviation. And this is going to help us try and figure out if something first is normal. Okay. So first, let's make sure we understand what something called the range is. So first is when we're talking about range, how we find the range is we look at it as the difference between the greatest value in a set of data versus the least value in a data set. So difference, remember, is subtraction, and the greatest means when we're putting the numbers in order from least to greatest, we go ahead and we take the biggest number and the lowest number, and we just go ahead and subtract them. That's how we figure out the range. Variability is something that we talk about when we're talking about the spread in the data. So how far apart they are. So for example, if we have this numbers down here and we were talking about the range of the data, well, I might want to go ahead and rearrange them. So lowest number is 2. And if I go ahead and I look through there, the highest number is, I see 13 is a big number, but I see 16 is bigger, but 19 is even bigger than the 16, and there's nothing bigger than 19. So it goes from 2 all the way to 19. So the range, we would say, is from 19 to 2, which is 17. So the range is 17. Okay. So now we're going to go ahead and we're going to look at calculating what we call the mean absolute deviation. So the mean absolute deviation is a very specific value, and what it does is it helps us figure out what's not necessarily what's normal, but kind of like what's typical. Okay, so it's something kind of like what's typical, or sometimes some people might say what's normal, but it's, if you ask a statistician if this is normal, but like just how far is it from the average, like how extreme is the data. But people interpret it different ways. Okay, so the first step is to determine the mean of the data. So you do, find the average of the data like you normally do. What's the mean? The next thing is you're going to take each value in the data. Okay, so this is a big step. So if you have a lot of data, this could be something where most people would be using a spreadsheet to do this. So you're going to take each value in the data and you're going to determine the difference. So that means subtraction between that specific number and the mean. Okay, so that's what we call the deviations. And we're going to take the absolute value. This is our third step. So absolute value means we're not going to worry about negatives. So if, we're talking about that the mean is 5 and the number that we're looking at is a 7, we don't care if it's negative 2. We want to know just that the difference is 2. Okay, that we're looking at, they're 2 apart. Okay, because we're looking at on a number line, how far apart are they from 5 to 7? They're 2 units apart. So that's what we mean by the deviation. Okay, so this is some data, so actual data from this past week of coronavirus cases in South Korea. So this is being recorded on May 12th, and we were having a really good trend, and then we had an outbreak again in South Korea. So we had only had 3 cases in the whole entire country a week ago, which were cases that had come from people who were flying into South Korea, not happening here, and then started going up this week. So yesterday we had 35 new cases in Korea. So we're going to go ahead and we're going to figure out first our mean. So we're going to go ahead and average our 7 cases. So we're going to go ahead and find the sum. So we're going to add. Okay, so we get that the sum is 108, and because we were looking at 7 days worth of data, we divide by 7, and we get that there was approximately an average of 15 and 4/10 cases per day. So that was our first step. Okay, so that was step 1. So remember, our second step is now we're going to go ahead and we're going to take each value in our data set and we're going to look at the difference. And remember, we want the absolute value. So we're going to kind of combine these 2 steps. And we're going to do this in an organized way. So now I want to go ahead and look at how far apart 15 and 4/10 is from 3. So if I go ahead and I subtract 15 and 4/10 from each of these numbers, that's what I'm going to be doing here. Okay, and those will give me my absolute deviations, not the means yet. Okay, so 15 and 4/10 minus 3, okay, would be positive 12 and 4/10. Okay, then 15 and 4/10 minus 2, 13 and 4/10. Then I'm going to keep doing that. And then 15 and 4/10 minus 12. Then I'm going to do it with 18. Now it's going to be a negative number, but remember, it doesn't matter if it's negative. You just use your calculator. And if your calculator on this one, we can ignore the negative number because we want the absolute value of it. So I'm going to go ahead and I'm going to do that again with each one. So now I'm going to do minus 36, or 34, excuse me. And then I'm going to go ahead and repeat, and this time I'm going to be using 35. So 15 and 4/10 minus 35, and I take the absolute value, so I get 19 and 6/10. Okay, so those are my absolute deviations. So I've taken the absolute values of each. I've taken the difference between the mean, okay, and the values in the data set. So I've gotten the deviations, and I found the absolute values of each. Okay, and now I'm going to determine the mean of the deviations. My mean absolute deviation. Okay, so I'm going to add all of those absolute deviations there. So let me go ahead and do those. So 12 and 4/10 plus 13 and 4/10 plus 11 and 4/10 plus 3.4, and I'm going to keep going. Okay, so I get the sum to be 81 and 4/10, and now I'm going to get the mean absolute deviation. It's going to be that divided by 7. And remember that we are going to round it to the tens place. So we get that it's approximately 11 and 6/10. So about 11 and 6/10. So that means that it's typical for it to be from the mean, okay, that which was about 15 and 4/10, to be a bigger than it by 11 and 6/10, or less than it than 11 and 6/10. So it wouldn't be far off for it to be 11 less or 11 more. So 35 for that week was an extreme, but 2 was an extreme low, but 18 wasn't too bad of an extreme. Okay, And that's it. Thanks.